So the question says, a current of 15 ampere was passed for 30 minutes through a solution of silver triazonitrate 5 between silver electrodes. Which of the following observation will be correct? 1 Faraday is 96,500 coulomb. I says the original silver ion concentration of the solution remains unchanged. II says that the original silver ion concentration of the solution decreases. III, the original silver ion concentration of the solution increases. IV, 0.280 mole of silver is dissolved from the anode. V, 0.280 mole of silver is deposited at the cathode. And then you have your options here where A is I only, B, I, and IV, C, I, IV, and B, B, I, IV, and B. So what will be the perfect answer to this question? Now, first of all, let us bring out the parameters that we have or we are given in the question. So the first parameter we have here is a current. And this current, we represent this current with I, 15.0 ampere, was passed for 30 minutes. So we have time, T, 30 minutes. However, looking at this question says that current was passed through a compound. And each time that you hear current passing through a compound, you should know that that compound is an electrolyte. And then you have something like is discharged, is deposited. We are talking about electrolysis. So in electrolysis, we measure time in seconds and not in minutes. Hence, this is given in 30 minutes, but I have to change to seconds. And how we change minutes to seconds is by multiplying by 60. And if time was given in hour, how we change hour to second is by multiplying by 3,600. That is, we multiply by 60 and another 60. So T is equal to 30 minutes. But I'm going to change this to second by multiplying by 60. So 6 times 3 is 18. This 20 comes here. Through a solution of silver triazonitrate 5. Now, like I said, current is passed through these. This here will now be or is known as our electrolyte. So what's the chemical compound representing silver triazonitrate 5? We have silver triazonitrate 5. Now with electrolysis, we see that once current passes through an electrolyte, chemical decomposition will occur. And when this chemical decomposition occurs, the electrolyte is dissociated into its respective ions. So if current passes into this electrolyte, this compound will dissociate. It's just the same thing as a conductor. But what differentiates this from a conductor is that while this is a compound, conductors are usually elements. For example, sodium is a conductor. However, sodium hydroxide is an electrolyte. So this conducts electricity because it's an electrolyte. However, if a conductor will conduct electricity but will not dissociate, because if you look at it, this is just sodium. So how many ion is here? Obviously, one ion is here, just sodium ion. But here you have two elements. This is an element, this is radical, combining together. Two different ions combining together to form a compound. So once current passes through an electrolyte, because it is a compound and a makeup of different ions, that electrolyte, which is that compound, will dissociate itself, will separate into its respective ions. So here, when current passes through this, we are going to get silver and triazonitrate. This is a radical, this is a metal. All right. Which of the following observation will be correct? 1 Faraday, we have 1 Faraday as 96,500. Now, because we have values here, 0.28, 0.28, it means that calculation was done here. And we have that is 0.280 mole. So firstly, let's confirm if any of these is correct. That is, if the mole of silver deposited is 0.280. So this is silver, right? This is the silver deposited. Now, in electrolysis, there's a formula we use that involves IT and the values we have here. And that formula is that mass all over molar mass equal to Q. Q here represents quantity of electricity over N. N here represents oxidation number times F. F here represents Faraday. And as you can see, 1 Faraday is 96,500. However, what you've been given here as value is measured in mole. And then in chemistry again, we have that number of mole is equal to mass over molar mass. And hence, this is mass over molar mass. So I'm just going to clean this and I'm going to represent it with N. Since N is the same thing as mass over molar mass, right? Now, Q here, quantity of electricity, can also be equal to current times time. So Q is equal to current times time. And then we have current here, we have time here. So I'm going to also clean Q here as well and replace with IT since we have IT. Right, so I'm going to clean this and replace it with IT. Now, what's I is 15 ampere. What's T? T is 1,800. What is N? Now, what is oxidation number? Oxidation number will be the oxidation number of the element that was discharged. In this case, we say silver was discharged or deposited. Now, this here is the oxidation number, as you can see. And the oxidation number of silver here is +1. This is why you need to know your electropositivity and your electronegativity series and also your radicals. In my videos, one of my videos, I explained this and I talked about it. And of course, also give you mnemonic that you can use to recognize your electropositivity series without cramming it. Now you have the oxidation number of silver is 1. And 1 Faraday, as you can see, is 96,500. So 1 times 96,500. Now let's calculate this. All right, so I'm using a calculator. In your exam, you're going to be given the system calculator, which can only allow you to multiply, add, and divide. However, if you're going to be doing complex things like sine, cosine, you won't be able to do that with the calculators you'll be given in your exam, whether it's Jamb or post-UME. So now, the only time you have that ability, it's in your YF. But if you're going to write in Jamb, or you're going to write in post-UME, you're not given that kind of opportunity. So we have 15 times 1,800 divided by 96,500, 0.279. So 0.279. And if you approximate this, you're going to get 0.280 mole. Now this has been sorted out. So 0.280 mole is correct. So 0.280 mole of silver did something there, but we don't know what it did. Now we've gotten 0.280. Let's come back to the question. Follow me and listen carefully because I'm about to explain one of the most important rules of electrolysis. Now, the option I says the original silver ion concentration of the solution remains unchanged. First of all, what electrode was used? Silver electrode was used. A metal electrode was used. And in electrolysis, we have 3 things that determines what is going to be discharged at either your cathode or your anode. Number 1, we said that is the nature of electrode. Now, what does the nature of electrode says? It says that if the electrode used is inert, meaning that the electrode used have no ability to interact with the electrolyte, electrolysis or what's going to be discharged at the cathode and at the anode will follow the rule of the position of ion in the electropositivity series. That is why I said that it is important that as a chemistry student, you master your electropositivity series and your electronegativity series. And this is not very hard to know. You can just use my mnemonic in mastering it. And I have a video on that. You can go to my videos and check for it, and you're going to see it there. So if the nature of the electrode is inert, and when we talk about inert electrodes, there are just 2 inert electrodes we use during electrolysis in this basic level, which is the platinum electrode and the carbon electrode. Your carbon electrode can also be referred to as your graphite. Now remember that graphite is an allotrope of carbon. So when you see platinum electrode or carbon electrode or graphite electrode in a question involving electrolysis, bear in mind that these electrodes are inert. They will not react with the electrolytes. So the rule, it's going to follow the position of ions in the electropositivity or electronegativity series. And now what does the electropositivity rule says? It says that metals below in the electropositivity series will be discharged in place of metals above. That is, if in my electropositivity series you have potassium and you have sodium and you have calcium and you have magnesium and you have aluminium, and of course these are all positive. Now if in an electrolytic solution these two ions, you meet these two ions, which will be discharged or which will be deposited. Now this is silver, this is potassium, and this is calcium. Calcium is below potassium, hence calcium will be discharged. Remember I said that the elements below in the electrochemical series are the ones to be discharged. This applies to the electronegativity series as well. Like I said, what I have here is the electropositivity series, so it applies both to the electropositivity series and also the electronegativity series. I hope you got this. So come back here. Now the electrode used here is silver electrode. It's a metal. Now what does the metal rule say? It says that if the electrode is a metal, then it's going to interact with the solution. And now when the electrode has a metal of the electrolyte used, for example, electrolyte used here is silver triazonitrate and electrode used is silver. So meaning that the metal used is part of the salt or the electrolyte used in the reaction. So what's going to happen? Once you see a case like this, the cathode, that is where cations will go to, will be unaffected. However, the anode will be affected. So once you see a question involving a metal used, which is not an inert metal or inert electrode like the platinum, carbon, and graphite, where you see a metal used, your cathode has no problem. So your cathode is going to follow the position of ions in the electrochemical series. But in the anode, the silver electrode itself will dissolve. The silver electrode itself will dissolve. Hence, you're going to be having an extra ion at the anode. And remember, silver is electropositive. So the silver electrode will dissolve to form another cation. And this cation will not be deposited. Rather, this cation, because it's positively charged, will flow to the cation, will flow to the cathode where it will be deposited. So at the anode, what will be deposited if the metal of the electrolyte is used? Nothing will be deposited at the anode. However, the cathode is safe. Use the rules you know. Position of ion in the electrochemical series or concentration. However, concentration affects your anode. So nothing affects the cathode in this situation. You get that? Nothing is going to affect your cathode. However, in your anode, nothing will be deposited. But look at what is going to be affected. Now, because part of the electrode has been dissolved to form another ion, the mass of the electrode, which is the anode, the mass of the anode will decrease. Because part of this anode has been dissolved, the mass of that anode is going to decrease. Why? As that cation that has been formed from your anode flows to your cathode to be deposited, the mass at the cathode will increase. So what happens in this is a loss in mass rather than a discharge of ion. What happens at the anode is a loss in mass of the anode, and what happens at the cathode is a gain in mass. Now, do you get this? At the cathode is unaffected. At the anode, the electrode itself dissolves. So you're not going to be having only NO3. You're going to be having NO3 and silver. Now, do you understand this? Let's come back to the question. The original silver ion concentration of the solution remains unchanged. Yes, concentration of silver ion will remain unchanged. The original concentration of the solution decreases. No, it's not going to decrease. Original concentration of the solution increase. No, it's not going to increase. 0.280 mole of silver is dissolved from the anode. Yes, remember I said that the anode will dissolve to form an ion. Anode electrode will dissolve to form an ion. Remember that silver is a cation, so it's going to dissolve to form a cation. So 0.280 mole of silver is dissolved from the anode. Yes, it is dissolved from the anode. Now, like I said, once this anode is dissolved, it will flow to the cathode to be deposited. So we said 0.280 mole of silver is deposited at the cathode. Yes, because 0.280 mole of silver has been dissolved in the anode. This same amount of silver will be what will be deposited at the cathode. Now, I hope you understand this. When a metal is used in electrolysis, the cathode is unaffected. That is, the negative electrode is unaffected. However, the positive electrode is affected, and this is how it's affected. Rather than the cation to be deposited, the electrode itself will dissolve, and this electrode will go to the cation because this electrode is positively charged. The electrode, the cation formed from the electrode is a positive cation, so it's going to flow to the cathode to be deposited. And the answer to this question would be I, IB, and B. So this is the answer to our question. I hope you understand this.